It's a really great pleasure to be with you again for a presentation on Omniverse Kit. Today, we will go over these 5 big topics. First, I want to go over the Omniverse Kit platform again. We will do a recap on the great features that we had added for Kit 102. We will talk about the introduction of Omniverse Code and how it can help you as a developer to build great applications and extensions. We'll get an overview of the new feature in Kit 103 and what it can mean for your new apps or extensions. And then at the end, I want to leave some space to talk about the call for developers and how we can all work together to build great new things. Okay, let's go on the platform recap first and go over our usual discovery. I know many of you have seen this video before, but we have a lot of great new software into the Omniverse platform, and I want to cover those for them again. We've shown this slide in the past, the 5 pillars of the Omniverse, the pieces that enable us to build this great platform for collaborations and simulations and real-time work all across our different industries. But I want to highlight these topics in the focus for what it means for you as a developer of tools and applications. First, the Nucleus Server, a shared database of storage for your work, but also real-time collaborations. It means that your applications and your extensions can be connected and bring live collaboration with ease and without you having to do a lot of work. It's a very great and important feature. Connect means that all of the different connectors and connections that we have with the various applications in the ecosystem can connect with your extension or your applications. You can build something that connects with Maya or Houdini or Unreal in a very easy way, and things that are really interesting for you as you focus on the added value that your work brings. Of course, Kit, we're going to talk at length today as the software development platform for Omniverse that enable you to create these extensions, these UI, these microservices, a breadth of work. And we'll talk about some of the new developer tools that we're adding for the platform as well today. Simulations. Applications need to have simulations. They need to have physics. They need to have fluid dynamics. You want to be able to have animations or AI. So much in the platform helps you to bring these great features into your application by leveraging the great engineering works from the open source community and NVIDIA. And finally, of course, you want to visualize these 3D worlds. You want to interact with them. You want to have a real fast renderer that enable you to see this really large complexity and be responsive, worked on multi-GPU, multi-node when you want to make large simulations. The RTX renderer technology brings that into your applications so you can have this real-time preview. All of these ones on their own are already great, valuable assets for you to construct great applications from these technologies. But when combined together, and connected with each other and layered into great ways, you are able to create instantly, maybe not instantly, you still have to do some work, but rapidly, incredible applications that will really wow your customers or your users or fill your requirement for your enterprise. And we're really excited about the many works that we're seeing coming from all over the industries working with Omniverse and with the NVIDIA team. A lot of this, and it's important to reflect, is powered by the USD frameworks. The Universal Scene Descriptions was initially developed by Pixar, but now collaborated by many, many partners in different industries. It is at the foundation of NVIDIA Omniverse. And one of the key aspects is because it's open and available in many different places, your work, the tools that you're making, the files that you're generating, the workflow that you're implementing are free to interact with other parts of your pipeline, other parts of the tools, other people's ideas. NVIDIA Omniverse just supercharge your development of USD-based applications. And so it's really important that you understand that USD is going to unlock a lot of power to your workflow and your applications. And NVIDIA Omniverse is investing a lot to make that the platform of the future. We've shown that slide, and I want to go back again as what it means for a developer and do a build up so you see the various aspects and why this platform is many different parts contributed by thousands of engineers across the company. Of course, it relies on tens and tens of years of research in best GPUs and continuously improving, the RTX GPU stacks and many of these other solutions. We have a lot of great core framework at the lowest level. We talked about USD, that we are investing a lot of energy to make the best possible, the RTX technologies, but new, and of course the CUDA technology, which is also very mature technology and used by tens of thousands, maybe hundreds of thousands of developers throughout the world. We're adding new technology to that low-level foundation stack, like OmniGraph, really important graph foundations that you'll see in many of our presentations over the coming months. And Warp will have also some discussions, but a great way for you to be able to easily write accelerated GPU code. There is a lot of libraries developed by many teams outside of Omniverse, inside NVIDIA, many of them open source, working with the community, both in the rendering field, where you have streaming, correct cloud XR, material definitions, and of course, expertise in rasterizations and ray tracings. We talked about simulation, the importance of simulations around having physics and fluid dynamics, and of course, all of the work in AI, many of them, many more to mention. On top of all of those is where the Omniverse platform is. We've discussed about these 5 important pillars. And then the extensions, a world where you can create a lot of building blocks, where you can reassemble the one that we provide, the one that partners and ecosystem players will create and share with the world, and then reassemble into new forms to create applications and microservices. Application for your user, microservices to run in the data center headlessly as pipelines. It's a very important way to build these new decentralized applications. And finally, of course, Farm. That is a coordination layers to run these applications and these microservices in a distributed way throughout the infrastructure, internally or in the cloud, to enable for your applications to be truly decentralized and running into a modern fashion. I want to go into the Omniverse Kit platform in some of the details. Often people ask, what is Kit? How is it functioning? What's the different pieces? And so I wanted to go and try to break it down into parts that would make it easy for everybody to get a sense of how the pieces that Kit is made of. So let's go over these bigger box abstract diagrams, just so you understand some of the core terminologies. And then later we will go into each of these ones and talk a little bit of what they're comprised of. So inside the Kit SDK, there's 2 really different parts. The low-level Kit core is a very thin layers of application runtimes, a bootloader, bootstrapper for your applications. We'll go into details what it is. After that, everything else is an extensions, either core extensions, or we'll see some of the other ones. Core extensions are a set of extensions that are really fundamental building blocks that we've added inside the platform, and then we're bundling into the Kit SDK, so you have a base to start from where you can bring a lot of different things. Above that, there is the shared extensions. Everybody in the company at NVIDIA, but many companies now outside, are creating extensions using the Kit SDK and its API, also its core extensions, to create their own set of work. And they get shared between multiple applications or multiple services at the top level that assemble extensions from the shared extension layer or the Kit SDK, including extensions that you might have built into your own enterprise, and then create them into applications that the end user are using to do their works, or microservices that are running inside the data center constantly. So let's look at a couple of examples of these different parts. We've talked about the low-level Kit core. At the lowest level, the Kit executable is really a little bit like Python executable. It is a small, lightweight runtimes that include a C++ core, a Carbonite library, and some Python logics in order to bootstrap the extension manager, some messaging and signaling on the platform. But it is very small. In its own, it is doing very little. Above that is a layer of first class extensions that will bring you UI functionality, core applications, the Kit microservices that will bring the USD libraries into an extensions that you can use directly into your other works. And of course, leveraging Hydra will connect to the RTX renderer and also many other renderers. Those libraries coming from different places are wrapped around these extensions so they can be made freely available inside the platform. Built upon those are a general set of valuable extensions that we are including inside the SDK, so you have this consolidated space to do your work. Those range from things that are mostly UI and APIs, like the graph editor or the script editor, some way to browse your content or your files. The physics library gets bundled there so you can use it directly. The extension manager UI enable you to see all of the extensions that are in your system, add them and interact with them, and a various sets of USD related window around the management of the stage or the management of Hydra for the rendering settings or the 3D viewports. Those all packaged together represent the Kit SDK, the one that we talked about, generational SDK, Kit 102, Kit 103. Those are our generational SDK that bring all of these technology together. But at a higher level, outside of the SDK, is the wealth of extensions. Many that we've built and share. Many different teams across our company are starting to build them for their works and their simulation needs. But many other companies outside of NVIDIA, our partners, are creating them either to share publicly with their customers or their users, or to use in their enterprise to power their digital twins or their simulation workflow. Those would be things like an MDL editor, the action graph that you'll see a lot during GTC, the material browser, asset browser, painting tool, particle, you name it. Everything could be built upon the Kit SDK, leveraging the public API, and then largely written in Python. Once we have all of these extensions and this functionality, they can be packaged and assembled into purposed full applications that serve great workflow for the end users. There's great examples that are today available from NVIDIA in the launcher, like audio to face for face simulations. Of course, the Create applications that enable you to create beautiful imagery, View for review and approval, many others that are there, including some internal applications that are built around driving simulations or Isaac simulations, and some of them shared with you in the public. Many of those also are services, not applications with a GUI, but services that runs in the data center or in the cloud, like Omniverse Farm that leverage many of these pieces. All in all, a very modular platform where at many different aspects of the stack, you can create your own innovations, and written largely in Python in the user space level of extensions. So you have a lot of reference code and example for your work to start. Okay, so let's recap a little bit on the great feature that we had on Kit 102. They are still there. They are still great resources for you to build your work. There is a large set of tree views and tree widget, list widgets that you can use to create your applications in terms of visualizing your files, the object into your world, different things that you're searching. Many of those in the applications are completely written in Python, and so you have full access to them. The Omni Ui graph framework is used throughout our applications in order to create great interactive graph with many different shapes and forms that can help the developer transmit their message. It is used in the extension manager to show the dependency between the extensions. It is used into the material graph editor. It is used in OmniGraph in multi-different form, and we'll see a little bit of an update about that today. We also use it in some of our developer tools to show dependency of Python call trees and complexities. All in all, a very flexible framework for you to create graphs without having to do a lot of work. But of course, you combine the graph framework with the list view, the viewport, the grid view into making really great, interesting workflows. We also shared these libraries that has been very popular and very much used by many different internal teams, but also externals. The Kit browsers. It's a very easy way for you to display grid data of informations around your assets, being able to customize the workflow when user click, interact with the search, and different things. They're used in various of our browsers. And today we will see also where we're bringing new advancement to that platform for 103. Again, very easy way to start. Many of those have very small example that you can use in Python to get your own browser started. I always want to remind you about microservices. The Kit platform is designed from the ground up to be disaggregated. That means that all of these extensions really want to run as microservices so they can be deployed in the data center and in the cloud. One of the ways that your extension can connect with each other, and we talked a little bit about earlier, is leveraging the Nucleus platform. Leveraging Nucleus, your extensions can connect with all of the other Nucleus connected things, which could be DCCs, 3D applications like Max or Photoshop or Unreal. They could also be your own other extensions. There's many ways to connect these things together in really interesting workflows. But the Kit microservices platform is also a very open and simple platform at the very base that's enable you to create lightweight microservices that will talk to each other using standard and open protocol that are well defined into the microservices industries, enable you to run small Kit functions across your data center to make operations. But of course, these Kit functions have the full power of Kit, so they can scale up to be, a supercomputer simulation functions or a rendering function that leverage physically accurate and super fast real-time rendering. That's what Omniverse Farm showcase by providing a platform to distribute these microservices actions and tasks across your data center and enable you to do tasks that can go all the way to be building very large simulations or rendering tasks. Omniverse Farm has been used throughout the company to render a lot of really great imagery, for example, that you're seeing during this GTC, and then we're using it for a lot of other workflow, both simulations, synthetic data generations, and image generations of all kinds. Those are just a few snippets of what is available already in Kit 102. Again, your place to go and discover functionalities and features is through the extension manager. We have big ideas about how we're going to evolve the platform for the extension, and tell us your feedback, but it's already really great and easy to use. Find the extension manager into the windows. You get presented with that simple UI. You can search many of these extensions, select them, have some information about them. You can see in some of these menus, you have access to change logs, and you can see dependency. You can enable them from there. You can even go and access their source code and open them directly into VS Code. Discover and find things. There is a wealth of information, way too much for me to go over in just an hour here. And of course, we have great learning resource on the web. You have the NVIDIA developer platform where you can find documentation, get access to our forums, tens of videos on the developer platform itself, but hundreds of videos on Omniverse, so you can understand how connectors are working, so you can understand how some of these 3D applications are working, or see what other people are doing and building with the platforms. There's obviously our great documentations, and we continuously invest and work in making it more complete and more detailed, and we love to hear your feedback. But there's many more videos that you can watch following that one to learn more about the platform and discover new things. Okay, so now I want to switch gear a little bit and talk about a new application that we have built using Omniverse Kit. we have always felt that our developers needed some custom environments, a developer IDE, a place that will be fine-tuned for them in order to create their application and extensions. And so that's where Omniverse Code come in. It is akin to an integrated developer environment. It helps you to build your extensions, your apps, or your microservices. It is simple to learn. It has this easy interface. It is well connected with other IDE, for example, Visual Studio Code that we use for all of our Python developments. But you can also easily connect your text editor of choice because we have the live synchronizations of the data. It showcases a lot of our great documentations and interactive tutorial that you can look and use. And you are in that environment where your code can execute straight away. We're adding a new tool to code that we have been working all last year and are really excited to share with you today. We call it Omni Ui Inspector. But before I go over it, or instead of going over it in a static image, I really wanted to give you a feel of the interactive nature of that tool. And so I created that video. Another great extension that we've added to the SDK for this release is the Omni Ui Inspector. This extension, you will find it into the extension manager as always. And when enabled, you get access to these great new windows that enable you to do a lot of really interesting things. You're able to pick any of the windows that you have running in runtimes and inspect its 3 views of Omni Ui items, seeing them one by one. Once they are selected, and also in general, you are able to have a preview of that object. Of course, that's similar to the stage view here that we have on the right, but you are also able to see the wireframes, so all of the Omni Ui elements and their bounds with this little tooltip preview that enable you to understand who they are. You can of course overlay both of them to start understanding what are your bounding box and maybe why some of your layout are not acting like you want. What's interesting as well is you can do a 3D view and rotate and visualize your tree view in a scene graph, so you're able to better understand some of the layout elements of your views. Once you're there, you can also see all of the property of the different object. Here we see that we're able to see what is the effect of changing the width and the height of some of these objects. And any of these objects will reflect their properties. So in real time, you can affect them to better understand the actions of those properties. The styles are also exposed. We see that here for these extensions, we use these cascading style sheets that are all set up at one of the top level of the tree. And they include a lot of things around buttons and filters. See here, for example, if I update the margins that is set around these buttons to be bigger, and we can directly see how that affects the layout of my object, better understanding what margin could do to the updating my code and fixing some of the issue that I might have found. This will also work with colors, and you can add them here. Let me just go and see the background color of that object and say, maybe this gray doesn't fit me, I want darker. Oh, look at this deep black here, or maybe some subtle tint coloring. Very interactive. Then you have mechanism to copy these styles, share them with your designers. Really great way to learn the complexity, but the depth and richness of Omni UI, so you are becoming a master of creating great UIs. There's a lot more to see about Omniverse Code. And back in December, we had made a great intro videos that I recommend you go and watch to see the various aspects of the platforms. Okay, let's deep dive into what's new in Omniverse Kit 103. We've added a lot of great features, and so I want to go over some of the key ones that you have for a developer perspective and what do they mean in terms of the tools that you're now able to build more rapidly. We did a lot of improvement to Omni UI by adding a couple of key frameworks that you will really enjoy and that will unblock some great possibilities. The first one of them is called Omni Ui Scene. It is a framework to build 3D widgets and manipulator for your applications. You can create shapes in a 3D projected sense. We'll go over the list of the shapes that we support initially. It is, as Omni UI, completely accessible in Python. using a simple and easy to learn Omni UI syntax. It is actually also available in C++, and over time we will talk about our opportunity there. But for now, think about it is as easy as Omni UI to build 3D objects in the 3D world. We have many shapes like text and image. Again, I'll go over those in a second. It is also connected with gesture. We've had a lot of discussions around how to make interactive UI, and gesture are a great way to interact with these 3D shapes. So they can be manipulated. You can move them around, you can click them, you can double click them and do a bunch of things. And those are connected to models that will enable you to make these gesture and these shapes affect 3D objects, other objects into your world, so you can connect them together. And we'll look into those. Here in this image at the bottom, we see a small 3D slider that has been created above this object that maybe would be connected to the scale of the object, for example. And on the bottom right, you can see one of these 2D manipulator that would be used to move a set of points into a 2D grid. Again, if you look at the right side, you'll see this circle and these two lines created very simply in a very traditional Omni UI way, where you create this scene view widget that you can add into your compositions by giving it some properties. And then with that scene being in scoped, you can inline create these simple shapes like lines and arc that will be retained by the model. Again, a very simple way of creating these things, and then very interactive. We'll go over some of the features together. I want to just go over these shapes. Simply, I will go over them fast. There is a lot more documentations inside the interactive documentations. Of course, you can create lines with a start and end. You can control their color and their thickness. You can control arc that will do, partial arc all the way to obviously full circles. They can be wireframe or filled. Here we see the wireframe version. You can create rectangles. Here's a square, but you can create rectangle. You choose the shapes, widths and heights, and choose the color. The wireframes, they can also be wireframes, so you can create them with non-filled colors. You can add images. Remember, it's Omni UI images, so they can come from the web, they can come from a Nucleus Server. There is multiple opportunity there. They're actually backed by the UI provider, so they can even be dynamic things. And we'll see some really interesting example in the next slides where we look around widgets. You can create points, so you can create a large series of points and they can have varying colors and size, and then you can represent them into your 3D world. Again, here we see them on 2D projected scenes, but all of these shapes are in the 3D environments where you can freely manipulate the camera projections. And of course, you can create labels, the same as Omni UI label, but they are in 2D worlds, in 2D space. They are facing camera all the times, but you can create them very similarly to what the UI label would be. Okay, I want to just go over briefly around these manipulators. I'm not going to go over too much of these diagrams. We will have follow-up presentations or maybe discussions around the general things around manipulator. What's interesting is manipulator are one of the three other concepts with the shapes and the gesture that are important for you to interact with the 3D scenes. We've talked about shapes, so they represent things in the world, objects, shapes of some kinds. Gesture are interaction between the mouse or the VR, Tanfix or other ways between the user and these shapes. They create intersections and they calculate some motions around those, and those get passed to a model. And the model object is similarly to Omni UI, a binding between these actions and some backend object, maybe a USD prim, or maybe a vertex CV, or maybe just some other concept that you have inside your applications. It enables you to create generic manipulator that can be bound to the data in a way that is very modular. All of those working together enable you to create really great manipulators into your world. A new great extensions that leverage all of the functionality that we just discussed is this new primitive manipulator that we have inside Kit, inside omni.kit.manipulator.prim. It is the manipulator that is used default into the viewport of the modern applications. It is a full set of manipulator for USD prims. So, translate, rotate, scale, different axes, global and locals. It is entirely built using UI Scene manipulators entirely in Python. Again, meaning that you have full access to this source in order to understand how these complex manipulators were built, so you can use and build your own. It is also very customizable, and then you can use it into the by changing some of its properties, so you can attach it to other shapes than a 3D viewport. Because of course, you can attach it to your own models. You're not bound to attach this manipulation to a USD prim. The model is separated, comes something that you can attach, so you can bind your data to those manipulators. Again, a great production grade example of how these frameworks can enable you to build really, really interesting manipulators. And we have plenty of other ones coming that will give you great ideas about what you could build with them. Okay, let's talk a little bit about Omni Ui Menu. Omni Ui Menu are here from the beginning, and we have them and iterate few places. But for this release, we really wanted to bring more vibrant and interactive menus, make it easy for you to build custom looks and designs. And so we are refactoring some of the classes that are relating to the menu system, but we have continued to support the old ways fully in a backward compatible way, so you don't have to change your code immediately, but only adopt them over time when you find that functionality is helping you build your applications. There is a new UI Menu Delegate that helps you to fully control the look of a UI menu items. It is very similar in forms than what we use for all of our other delegates, making sure the platform uses common patterns that are reused everywhere. We also had a lot of demand for menu to be able to be fully built dynamically on click, so you can create more procedural menu creation. So now the UI menu include a build FN that will build just in time the menu. It's cached, so it's fast to reuse later, but you can easily invalidate it, so you can also easily recreate it each time. There was many times where user wanted to put collections inside menu for like multiple choices. So we've added UI menu collections that enable radio menu button behaviors in a very simple way. The other things with the menu delegate is now the menu item can be fully re-implemented in Python in order for it to represent your item that contain the data that your delegate will then use to create these nice new looks. We are deprecating, but it is still supported in Kit 103, the UI menu bar that is now fully replaced by the UI menu that is able to do horizontal menu as well as vertical menus. So what does it mean for you? And we wanted just to share with you a little bit of these new possibilities. Well, you will see in our new viewport that we've fully adopted this new menu system in order to create the viewport menu. And these include all of these really great features and things that were not easy to do before. For example, you can see on the left-hand side better ways to have checked and radio, also the mixed button for some of your menus or your sub-menus. You can see on the second deck that you're now able to put right side actions. So on your menu, easily there can be buttons on the right side. In the center column, you see one of these menus that is an hybrid between a menu and a pop-up window. And what is made possible because now your menu can include full delegates that will control its build-up. And so in that case here, we show how you can start including sliders and checkbox and different concepts into your menu items in order to create very interactive and beautiful menus. On the right column from the top, you see that we can create these horizontal menu that enable you to replace the concept of UI menu bar. But these horizontal menu first benefit from the delegate perspective. So each of the items in that menu can be fully controlled by the delegates. So here you see menu items on that bar with just a button, just an image, or an image and a text, some image and some little informations that they will pop up and in which places. And they also have some mechanism where you can expand and collapse them to be able to really do that. And also mechanism to do left and right alignment, because you can insert UI menu separators or spacer in your flow that will push item on the right hand side of your menu. And in that bottom right corner, we'll see another great feature that is added into the menu system, which they can all be tiered off. You can obviously programmatically decide if that's possible, but once you create a menu, you can now tier it off and it will stand on its own inside anywhere in the window until you close it. So all in all, a large set of great new possibilities enabled by these new delegates and collections addition to the UI framework, still keeping backward compatibility. So your old menu continue to work very well until you decide to adopt this new pattern. Okay, so we talked a little bit about the viewport, and I want to bring a couple of interesting aspects to that. We've worked relentlessly throughout the year to redo the viewport stack using all of the modern technology that was brought into Kit 103. That means that you have a new viewport window that is rebuilt fully in Python, leveraging those new widgets. Means you have access to the source, you can see how the viewport is constructed, and that could inspire you to build your own or modify the one that we're providing. There is a new viewport widget, which is the single pane that is part of the viewport stack that enable you to maybe create different types of widgets or enable a widget of a viewport inside one of your pop-up windows in order to visualize certain things. This widget is backed by a low-level object still available from Python called a viewport texture, which is the very bare minimum widget that will connect the a UI image with the output of an Hydra render delegate. A lot of great details in follow-up sections. How do we interact with the viewport? Of course, we're using those new manipulators that we've just discussed. So a large set of manipulators have been rewritten and re-enabled for great camera manipulations, selection manipulations, and others. And again, then they all come written fully in Python, available to you, so you can appreciate how they're constructed. You can modify them if that's what's required your applications. You can also create your own and replace them into your applications to have your own ideas around camera manipulations or selection in the scenes. We've just talked briefly about the viewport menu bar or the new menu. It is of course built using the new UI menu system, and it is also fully customizable. So some API are made available. So as a developer, you can create your own menu item for the viewport menu bar and insert them inside the flow, so you can create extensions that participate to the viewport window itself. Another great feature is that the viewport window and the lower level of the stack now support multiple USD context. The USD context is the mechanism that's stored and wrapped around a USD stage, a 3D world. So now you can have multiple 3D worlds in the same applications. You can visualize them from different viewports, and then you can interact with them in different viewports, leading to great, really interesting multi-document workflows or pre-visualizations of scenes. Again, you'll really see great workflow coming out of that. And then there is also possibilities to create multiple instances of a viewport windows, enabling you to have multi-viewport workflows into your applications. I won't go into too much details about all the API that you have available with these new viewport widgets collections, but I just wanted to show you how simple and clear it is for you to now create your windows that includes a viewport. We see in these few lines of code there, importing the viewport widget at that moment, that simple widget that we discussed about. We're creating a simple window, a normal Omni UI window, and it's its frames. We're creating that viewport widget which you decide of a resolutions of 720p. Accessing the viewport API, we can change some of these informations, like maybe its resolutions, And in that space, it is created using the default context because this was not passed as a parameter. And then we are going to just change using the Viewport API, the camera path. In that case, we'll look through another camera, this world camera that was defined in that stage. And in this image that you see on the bottom, here is the result of these just few lines of Python. It is created a new window, your window, not a viewport window, your own window, that include a widget that is a viewport widget, and it is pointing to that 3D world using the camera. This is not manipulatable, you didn't have no menus, you cannot click on it because these features were not added or enabled by yourself. But you can start creating your own workflow in a very simple manner. And so with that, we're really excited, and we know that many of you have asked for that feature, and so we're really happy that we are able to bring that to Kit 103. Now, let's discuss about another really important feature of Kit 103 as it relates to rendering and the viewport. We discussed the viewport is powered by these viewport textures, which essentially provide you a bridge between the UI and an Hydra render delegate. From the beginning, Omniverse has been powered by Hydra, which is the library inside USD that connects the 3D USD world with any kind of Hydra render delegate. Of course, the RTX renderer is an Hydra render delegate, and so is the RTX ground truth renderer powered by the iRay technologies. But there are other renderers included inside USD, for example, Pixar Storm, that is also an Hydra render delegate. There's actually many Hydra render delegates that are created by all of the best renderers in the industry. I've listed some here. V-Ray has one, CycleX will have one that we're presenting soon, Redshift, Arnold, Random and Karma, and many others that I'm not mentioning here. And all of these renderers have, many of these renderers have expressed great interest to bring their Hydra render delegate to the platform. I'm just showing here in actions the CycleX Hydra render delegates that is being built in collaboration between the NVIDIA team and the Blender Foundation teams that will be available in the platform in the near futures. What's interesting with that scene that you're seeing here, which is a great scene from Blender that I exported using the Blender connector that exports from Blender into a USD. It leveraged the fact that USD provide multiple rendering context, multiple shader library support. And so that scene was exported with 3 different render contexts for the materials. One for MDL, a lot of shaders using USD shade and MDL. One for CycleX shader graphs, again using these USD shades. And then one using USD preview surface. Not 3 different files, just one files, one set of geometries and lights and cameras, but for each of the material, 3 different variants, different setups that are potentially accessible by different type of Hydra render delegates. That's exactly what's happening here, where at the top, the RTX renderer is using the MDL descriptions of these shaders to power the computation engine that will lead to these beautiful images. For Cycle, it will use its native shader directly connecting its Hydra render delegates with the CycleX renderer backend. And HD Storm will be able to leverage the USD preview surface networks and still support this great texture and lighting. All of the images here are not all exactly equals. There is still some work between the different companies and renderers and language formats to align completely. But the path is set that having fully interchangeable workflows where one scene can represent the world and then multiple renderers can look at them using their own special strengths. We're really excited about that development. It will bring a large set of great rendering technology into the Omniverse platform, enable a lot of great new workflow from everybody. Okay, I'm going to go over a couple of other things that we've improved inside the stack. We talked about the Omni Ui graph extensions, and again, it's used throughout many extensions, but it was a lot of work that happened in 103 to make it even easier to use and more powerful. One of these is the addition of these graph editor core extensions that wrapped around not only just a graph view, but also this great catalog on the left-hand side, ability to create toolbars, and many different advancements that makes it really easy for you to get started into a graph extensions. Inside code, there is a great sample that leverages this graph editor that you can clone and copy to get started in building a graph really great. And this is the screenshots that I've built here. Again, entirely written in Python, so you can inspect all of the different pieces to learn of how it's built. There was also the additions of a couple of great new delegates. Remember, the delegates for the graph are the extensions that generate the look for particular graph items. We had this one, the one of 102 at the bottom left, which we called the default back then, which is the one that was used into the material editor, for example. For this release, we're adding two new delegates. One called Neo, which is the one on the top left-hand side, which shows you slightly different arrangements of the nodes and different looks. Again, just so you see how these things can be constructed differently. And the new modern delegate, which is our new default, effectively for 103, which is the one that is used for the new action graph, and that looks really beautiful in all of the different shapes and zooming levels. Great to see it. All of those are available for you to use as a starting point for creating your own, or just use as is, so your applications doesn't have to bring custom UI element for the graph. I want to briefly talk about the RTX renderer. Of course, it is coming included into the Kit SDK. We discussed throughout the presentations how many of the technology get packaged and wrapped around these extensions, and we bring them into the viewport. And we see how that's powered our really beautiful and interactive viewport. I'm not going to go over these slides. There is a great presentation at GTC and on the launcher and the learn sections around the powerful feature that the Omniverse RTX renderer has, including its scalabilities. But today I wanted to talk about a couple of new features that the rendering team has added to the renderer for 103 that are interesting for developers, as they can bring you new opportunities. There is now support for curves. Curves, the normal basic curves, basis curve from USD can now be fully rendered inside RTX in all of its modes and really fast, rapid ways. And so that includes really interesting visualizations for curves in many different ways. And I know as a developer building applications, visualization of path, visualizations of certain primitives, it will be a very interesting features. There's actually also Manipulator for curves added to that, so you can start including curves into your 3D tools, leveraging Omni Ui Scenes, and even be able to ray trace these curves into your workflows. The second great feature is the support for AOVs. That means these arbitrary output variables that can be output from the renderers, from the simple color to the different passes around reflections or refractions, or the normal maps, the depth maps, the position passes, all adding up to these beautiful images. And those are really important in many different workflows, especially in the synthetic data generation world, where many of these AOVs will represent ground truth elements for the training data. And actually that's used in great effect inside the Omni Replicator platform that also comes as part of our 3D applications. So there's plenty of other great new features and speed improvements into the renderer. I just wanted to highlight these two as they impact your abilities to create great new extensions or workflow using the Kit SDK. We've also greatly improved the support of streaming, working in collaborations with the GeForce Now team that is providing every gamer with great gaming workstation in the cloud through our GFN platform. we have continued to improve the remote desktop streaming for Kit. There will be, in the coming weeks, new versions of the Omniverse Remote for the desktop that will come into the launcher that now enable you to connect at higher resolutions, 1440p and even 4K streaming, leveraging the native clients. And we have a lot of new announcements that we will make in the future over improvement that we're making to the streaming platform. But many different ways for you to leverage your applications running in remote nodes, in the data center, in the clouds, and then bringing them to lightweight workstations. So we talked a little bit about the great browsers that we had in Kit 102 and then how they were used in Create to make great browsers for assets and for textures and different things. For Kit 103, we're adding new advancements to the browser framework, mostly around the way you can visualize these left columns. Instead of having the combo box and a list view, you're now able to see them in a tree view and deep dive into many of the different connections, them still powered by a model. And this was used at great effect into a new extensions that is coming to the creative applications, including Create and View, inside 103, a batch of applications, which we call the asset stores. It is coming still in beta, but it's already providing a great and fun opportunity to use the browsers. It is connecting to great asset stores, some from NVIDIA. We are providing all of the assets that we've provided in the past into our browsers in there, but also connecting with the great resources from TurboSquid, all of the assets that Sketchfab provide, and in great actors and animations from ActorCore. Each of these asset provider connect with the asset store using a public API for the extensions, which is this base asset store. They are implementing an extension, an asset store extensions that re-implement that base class and provide search capabilities into their stores, including some mechanism to either download or grab these assets or redirect you to their asset store on the web. What is really interesting is each of these extensions are entirely written in Python, of course, you might have guessed, and they come available with the platform. And so what does it mean for you as a developer? Maybe there is another great asset store that you are building and running. Maybe there are asset stores that you are really interested into that you want to connect with in interesting new ways. You can leverage these API and build these asset store extensions, these asset provider extensions very easily and bring a lot of new assets into your platform. We're really excited about that platform and think that this will grow rapidly into a large collection and is a great opportunity for developers around the world. Okay, so I think we've discussed greatly about Kit 103. There are more in there that you will discover as you start installing it and using it. But for now, let's go over the platform as a whole and discuss briefly together. Omniverse Kit is a developer platform. It is a platform for you as a developer, as an enterprise, as a customer, to create tools and workflows and applications that will service the requirements of your work. We have providing a lot of resources for you to learn how the platform is and start your journey into creating your own application and extensions. I'm listing some of them there we've discussed in the past, but you have the developer resource, the Kit documentations, the overall Omniverse documentation, because remember, everything in Omniverse is a feature that you can connect with your development workflow in order to use them into your work as great effect. So you want to learn about physics, you want to learn about audio to face, you want to learn about the great new flow system or the different things that you can build with Warp, because they are all tools that you can use into your own applications to build your own workflows ultimately. And so I wanted to go over a couple of ideas, try to call for actions, to try to explain how broad and the platform can be for you as a developer. And I'm just going to go over some of these examples as we discuss over to tease your curiosity or maybe your imaginations into what you might build and contribute to the platform, either for your company, for your friends, for your social network, for some brand new ideas that you want to share with the world. You can create new type of manipulator easily with this new framework, like a UV editor or some great replicator for geometry. Maybe you want to build some great light manipulator that you've seen in other applications, but you have your own ideas and you can write them in Python in a very interactive fashion using the platform. You want to build something with graph. Graphs are great and they're really fun to work with. You can of course leverage OmniGraph and the new action graph to build new nodes, to connect them and create workflow. But you can also create your own type of nodes, connect it with your own node evaluation engines in a very easy way. You can make your node look any way you like. You can create node delegates and define your own looks and include images and preview of many kinds. You can create one of these new asset providers, connect with this new asset that you've seen on the webs or this company that you're trying to create and provide them to your users. There are great scriptability in the Paint tool, like script brush that can be written with events and different things. We've seen great new painting tool coming throughout the company internally. And we think that if you get into learning how to build them, you will have also a lot of fun. Of course, you can build a lot of microservices to use Kit remotely. You want to build your own little microservices that generate images, generate data sensitive generations. Plenty of things you can do with microservices. And then, of course, those are just examples. You can build something completely new, leveraging the low-level foundations of Kit, of Omni UI and services to really build something truly unique that will make a difference in the world. So those are extensions. Many of you ask us as well about how to build applications. And we're going to provide more example, end-to-end example over the coming months on how you can build applications. You are not bound to build an extension that will be then used in Kit or View or Create or View. You can create your own applications. All of our applications that we provide, Machinima, View, Audio2Face, are built exactly the same way that you can, as a Kit file and a set of extensions. Maybe you want to create a great asset viewer, very purposefully built for viewing your assets into your company, or a very cool lighting tool that manages lights and shaders and different viewports. You can also go outside of the world of 3D and build new things that don't necessarily need the viewports or maybe even USD. You can build great automation tools using the graph editor, connecting different tasks together. You can leverage the UI system on its own without any of the other piece to build UI for great library, maybe like Pandas or whichever is your favorite Python libraries, and try using Omniverse and Omni UI instead of maybe Python Qt to build it. See where does it take you, and I guarantee you will have a lot of fun. And then of course you have access to connectors. You have the Omni clients that connects to Nucleus. You have live USD editing, but USD can represent any data that you like. Why not create some great collaborative drawing tools that can be used by multiple different people across the world from different platforms? Just ideas to try to tease your curiosity about what you could build with Kit. Finally, and many of you have been asking us about C++. Of course, C++ is important and we use it extensively in our platform in any places where performance are critical. And so we want to enable you as a developer to also contribute to that. Note that it is already possible to build extensions that leverage C++ by building C++ library, Python binding, using the Python binding of your choice, and including this library and this binding inside your extensions. And then you can leverage that inside your tool. You can even interact with a stage by transferring the stage ID as long as your C++ library has been built in that context directly with our USD library to be able to match its API. But we are working toward getting the Carbonite API to the Kit developers, so you have access to some of the technology that we're leveraging in order to create a 3D library that are ABI compatible, that also have automatic Python bindings. And so please reach out to us if you have things that require C++ and you want to tell us about your use case, so we make sure that they're included. We are also going to expose the ability of creating widgets in C++ and manipulators. There are valid use cases. In many cases, you want to use Python for having great binary compatibility, for fast and iterative development processes. But we know that sometimes, and we do it ourselves, the Omni Ui library needs to be extended using C++ to create low-level foundational pieces, and then we will expose that this year. But tell us, what API do you feel you need access to? It is important that we understand the headers and the API that you feel you need to have access in C++, so we can plan to have them exposed in a way that they will be stable and consistent across the many iterations of the Kit SDK, so you have a great user experience. So please connect with us. Extensions in C++ are definitely coming. We want to do them right, and so for that we need your input and your collaboration. You can connect with us in many ways, in real time, all the time. And so I want to encourage and discuss a little bit about the community platform that we have. There is a Twitch channel, NVIDIA Omniverse on Twitch, where we do regular Twitch streams from the Omniverse platform. There are many, sometimes more than once a week. The developer team is trying to connect directly with its user base at least once a month, and we would be very happy to do them more often if we have enough of you joining us and asking us for different tutorials, a deep dive in some of the topics that we've discussed. We're also very active on Discord. There are many channels on Discord where many users are discussing in real time about their use of Omniverse, and many of our engineers are over there, and you can talk with them in real time and discuss about your ideas and your project and get direct information about your things. And of course, there is the great Omniverse forum, where thousands of people every day share messages and discuss topics, help each others, but it also is included and moderated by a large portion of NVIDIA engineers and community managers that are here to answer your questions and bring these feedbacks and these discussion to the engineering team. So we make sure that each time we deliver a new version of the platform, it addresses more of your needs and more of your feedback. Okay. It's been a great 1 hour, and I wanted to share all of this news with you, talking about Omniverse Kit, but also Omniverse Code, the tools that you use to build your applications alongside all of the other things. We're really, really happy that you spend this hour with us and learn more, but this is really just the beginning. There's so much more that you can learn and experience by interacting with the platform and the people that are contributing to it directly, and mostly create something. Use the platform to create something. Let us know about your experience. Let us know about your output. We'd love to see what you're building.